a very good one, 42 42nd one. So you should have electrostatics knowledge and magnetic fields, both of them, to do this, right? They're asking for this, how to pass without having a deviation, or how to go with the constant speed is what they ask here. How to go with the constant speed. An electron passes through the space. There's an electron. It passes through this space without deviating. It doesn't turn towards any direction. But we have an electric field and a magnetic field. So with the effect of the electric field and the magnetic field, they want us to find how it passes. Right? With the impact of the electric field and the magnetic field, they want us to find how it passes. We know when there is an electric field, there should be an electric force because it's a charge. When there is a magnetic field, there can be a magnetic force. There can be a magnetic force, not always. Because you know, in order to get a magnetic force, you can use the left hand rule, Fleming's left hand rule, FBI. Force, and magnetic field, B, and current, I, FBI. So if the current direction and the magnetic field direction are perpendicular to each other, then you'll be getting a force towards another perpendicular direction. So when the current and the magnetic field are towards the same direction, you don't get a force. There's something like that as well. So they're asking those spaces might have zero electric field but non-zero magnetic field. So let's show. We have to assess each and every one of these scenarios. Statement A. So we'll check whether statement A is correct. Electric field is zero. There is no electric field, but there is a magnetic field. So if the electron is going to go towards this way, the direction of current is this way. Right? You know the direction of current is opposing the direction of the movement of an electron, because electron is a minus charge. Direction of plus charges is known as the direction of current. So this is the direction of current, I. So if you have B also towards this direction or towards this direction, either of them, what is going to happen? I'm going to take this. Now it does not have a magnetic force. It does not have a magnetic force. FB is 0. So this can go undeviated with a constant velocity because there is no FB, there's no FE. No FB, no FE. So can go undeviated. Can go with constant speed. Can go. We'll take the second one. B. Electric field is not zero, but the magnetic field is zero. This is absolutely chaos, because if there is an electric field towards any direction, there should be an electric force. Say that you have the electric field towards this side. So definitely there is an electric force towards the other side. So we have to say cannot anyhow go. Constant speed, because speed always has to change, because there is a force, so there is an acceleration towards a certain direction, and we can go to C. When electric field is 0, when electric field is not 0, but magnetic field is also not 0. So both electric and magnetic fields have values. Yeah, let's see. Let's move towards this way. There is an electric field towards upward direction, let's say. So when there's an electric field towards upward direction, you know for sure there is a electric force towards downward direction. So we have to think a way that whether we can cancel this off or not. We have to think a way if we can cancel this force or not. So if you can cancel this force with FB, means that if you can apply a force FB towards this side, and if they are equal and opposite, then it can be, right? It can be. So how do you get an FB towards this direction? If you want to get it towards that direction, you know the current direction is towards this side. So we can apply FB, I and C, Fleming's left hand rule. FB is upwards, I is towards, FB is upwards, I is towards that direction. So magnetic field, if you apply towards this direction, say there is a magnetic field towards this direction, then you will be getting an FB towards this direction. So we can say if FB is equal to FE, it can go with a constant speed. So it may go with a constant speed. So statement A is correct, can go. Statement B is wrong. Anyhow, we have an electric force, so you cannot go. Statement C is correct. So the answer is A and C. Answer 4. It's a good question actually. It's a good question, a lot to think. And if you can figure this out alone, means you have a proper knowledge of electric and magnetic fields.